Hi there, this is Math 116. We're on section 2.2, and we're continuing on with our quadratic equations, and now we're looking at parabolas. So here's our quadratic equation. Suppose we have f of x, or y, is equal to ax squared plus bx plus c. Remember, this is the general form of a quadratic equation. Then the graph of this function is a parabola. A parabola is u. It's a u-shaped thing. I have several parabolas here that I can show you. So here's the basic parabola right here, y equals x squared. Here's another parabola that's shifted up. Here's one that's shifted over to 10. Here's one that faces down. So parabolas can be up, down. Here I could make one that's wider, 4x, 10x squared, like that. Let's see what that one looks like. But that one's skinnier. Okay, do you see parabolas can be like 0.2, trying to come up with one that's a little different looking there. Like that. Whoa! So parabolas are any of these u-shaped functions. You'll notice they have either a minimum value or a maximum value, like that's the maximum right there. So here are some equations that you need to know for parabolas. If a is greater than 0, then the function or the parabola opens upward, and if a is less than 0, then the function opens downward. So a is the coefficient of the x squared term. So you can look at any equation and already know if it's a parabola because it's a quadratic equation, if you have this x squared term, it is probably a parabola. And if the coefficient of the x squared term, or the squared term, is greater than 0, then it opens up, and if it's less than 0, then it opens down. Again, you can see this one, the a squared term is greater than 0, so it opens up. These all open up, and these two open down. So that's the first thing you want to keep in mind. And then we're also, for parabolas, we're interested in the vertex. That's the maximum or the minimum point. So again, you'll notice that each one of these parabolas, there's a point down here. If it opens up, then this point is a minimum. If it opens down, then it's a maximum. So here are some equations that you want to know. The coordinates of the vertex. If you have an equation in this standard form, y equals ax squared plus bx plus c, then the coordinates of the vertex, that maximum or minimum point, the x coordinate is negative b over 2a, and the y coordinate is just the function evaluated at that point. So you plug in negative b divided by 2a into your function. And then there's also an axis of symmetry at x equals negative b divided by 2a. So if you have a graph here, like let's look at this purple graph. This one, the axis of symmetry is going to be at x equals 10, right here. You can see this line, x equals 10. So this parabola is exactly the same. It's a mirror image on either side. So for these questions, they're interested in what's the maximum or minimum, and then what is the axis of symmetry. And I'm going to show you mathematically how to find this as opposed to just looking on the graph. So here are some questions. This is question number 9. Happily, this question number 9 is the same for the 10th edition and the 9th edition. It says, determine whether the function's vertex is a maximum or minimum and find the coordinates of this point. Find the zeros, if any exist, and sketch the graph. Oh my goodness, there's a lot going on, but we can do it. So here is our equation. Y equals x squared plus 4x plus 4. So this is question 9. And we have y equals x squared plus 4x plus 4. And the first thing is, it asks, is it a maximum or a minimum? Well, what you can do is you can look at this equation and you see that that's 1 times x squared, and 1 is greater than 0. So that's telling us that this opens up. So we have a parabola that does this. We know it has this general shape because it's x squared, so it's a quadratic equation, and the coefficient of the squared term is positive. So we know it opens up, which means this point, if you draw a picture, you can see that this point must be a minimum. So to answer part A, we know that the vertex is a minimum. And if you want to be really pure, you can say because like 1 is greater than 0, or because the x squared term, like a equals 1, you could also say that. But you don't really need to write because, you can just say it is. The vertex is a minimum. So what else does it say? Find the zeros and sketch the graph of the function. Oh, find the coordinates of this point. Okay, now we have to find the coordinates. Okay, well that's not too bad. We have a equals 1, b equals 4, and c equals 4. I'm looking at the coefficients of these terms, and I put them in order, x squared, x, and then the constant term. And our equation says that the vertex is at x equals negative b over 2a. That's probably something you're going to want to write on your note card. So negative b is negative 4. 2a is 2 times 1, so negative 4 divided by 2, yes, I'm going to go with negative 2. X is negative 2, but that's not a point, that's just the x coordinate. So now the function y evaluated at negative 2 is equal to, yes, that's right, negative 2 squared plus 4 times negative 2 plus 4. This is if you're being really, long about it here. So your answer there is 0, because that's 4 minus 8 plus 4. So the coordinates of the vertex, the coordinates are x equals negative 2 and y equals 0. So the question asked you, what are the coordinates? We're not quite done. These questions are long. So it says, determine whether the function's vertex is a maximum or minimum. We said it opened up, so it was a minimum. Find the coordinates of this point. We just found them. Now it says find the zeros and sketch the graph. Oh my goodness, it goes on and on. All right, I need a new piece of paper, new piece of paint paper. So to find the zeros, here's what we're going to do. We say, well, this is what we were doing in section 2.1. Y equals x squared plus 4x plus 4. That's going to be equal to 0. So the question's basically saying we have some, I shouldn't get rid of it. We have some parabola that looks like this. We know that this point is negative 2 and 0. So where does it cross the x-axis? So is the x-axis like well, it wouldn't be like that because it's negative 2, 0, like that. Okay, so y equals, the way we're going to do this one is we're just going to factor. I'm whispering, factoring, it's easy. This x squared plus 4x plus 4 is just x plus 2 squared. So you could also use the quadratic equation, that's always going to work. So this tells us that the zeros are x equals negative 2. That's the only zero. So there's just 1, 0. And that tells us, as we kind of see from our picture here, that the parabola only hits the x-axis in one place. So that's kind of my, when it said sketch the graph, there's negative 2, 0, and then negative 1 there. How's that for a nice graph sketching? So for the purposes of this course, a graph like this, if you just sketched it like this, would basically be okay. I'm noticing that the parabola opens up and you have the vertex. So if the question had asked for the axis of symmetry, you'd say, well, the axis of symmetry, I'll get a perfect line thing, goes right here. And the equation of that line is, better get my pen, x equals negative b over 2a, or x equals negative 2. The axis of symmetry is always going to be the x value of the vertex. Symmetry. Okay, so I believe we answered that question. It says find the zeros and sketch the graph of the function. I also sketched it nicer than I did by hand here. So that's the graph. See how beautiful that is? I'm not expecting you to graphic this perfectly, and it'd be nice if you knew that point there where it crosses the y-axis, the y-intercept, but it's not super important to me. So, next question. And notice this one was using this formula, the coordinates of the vertex, and I just added the axis of symmetry. Here's another equation, or question. This one's a little tricky. Question 13, again, is same in the 10th edition and 9th edition, says y equals x minus 3 squared plus 1. Tell how the graph, or state how the graph of y equals x squared is shifted, and then graph the function. So this one's a little tricky, but they have an interesting, they do something like this on, what page did they do it on? Really, the only thing you're going to get some help for is page 137. So again, let me get a new picture. So on page 137, there's, in the introduction to this section, there's a little bit of help. But here is my suggestion about how you do this question. So question number 13, here's our function. Y equals x minus 3 squared plus 1. So first you can rewrite this like this. X squared minus 6x minus 9 plus 1. I just expanded that out like this. I'm trying to get it in the general form. That's the same as x squared minus 6x minus 8. So that's the same function. So what we can tell from this function now is that the vertex, so notice again there's 1 there, so it opens upward. So this point right there is a minimum. And the vertex is at the point negative b over 2a, which is equal to negative 6 over 2 times 1. So that 6 divided by 2 is 3. So the x-coordinate is 3, and the y-coordinate is equal to, if you plug in 3 here, you get 3 minus 3 squared plus 1. That 0 plus 1 is 1. So the vertex of this problem that we have is, or this function, is 3, 1. 3 and 1. So if we plot it like this, 1, 2, 3, 1, the vertex is like that. That's the point 3, 1. And then it opens up, so we have a function that looks roughly, sorry, that was a terrible parabola. It's a horrible parabola, but you get the point. And the function y equals x squared, let me get a different color, looks like this. Y equals x squared is a perfectly centered parabola that opens upward. That's x squared. So we can tell, I'm using the shifting of the vertex to tell how the function is shifting. So this one is at the point 3, 1. So the answer is it's shifted 3 to the right and up 1. And up 1. So up 1. That's the answer. So let me go back to the question to prove to you that I have answered it. Tell how the graph is shifted and graph the function. There it is. It's shifted 3 to the right and up 1. And I did that by finding the vertex of the new graph and comparing it to where is that coordinate shifted. And if you want, you could also do this graphing. Here's the graphing right there. 3, 1, so it's over 3 and up 1 as opposed to y equals x squared, which looks like that. So I have one more problem I want to go over, and it's this question right here. Question number 31. It's a profit function. It says the daily profit from the sale of a product is given by this function. The profit equals 16x minus 0.1 x squared minus 100, where x is the number of items sold. What level of production maximizes profit, and what is the maximum profit possible? So this is how you do these. You can imagine, oops, fill, I say. So this is, yes, it's a parabola. Did you see that one coming? So question number, no, here, 31, cancel. Sorry guys, question 31. Here we have a profit is equal to 16x minus 0.1 x squared minus 100. So we can tell, I'm going to rewrite this in the general form, minus, I'm just rearranging the terms so that they match. Okay, so this right here, finally something that is not positive. So that is a negative coefficient, so that tells us we have a parabola that opens down, which is good, so it opens down because the x squared term is negative. So that means right here, that's going to be our maximum profit. So the reason this question is in the parabola section is that the vertex, the coordinates of the vertex are going to be our maximum profit. So what level of production maximizes profit? Well, we use our coordinates. We know that the x value equals negative b divided by 2a. In this case, that's negative 16 because that's b, divided by 2, and a is minus 0.1. Don't forget the minus. And all of that equals 80 because that's 16 divided by 0.2, and the negative signs cancel. So your answer is x equals 80 units maximizes profit. So you would make 80 units if you want to maximize profit. And then the maximum profit is just the function evaluated at 80. So that's 16 times 80 plus 0.1 times 80 squared minus 100 equals, yes, $540. So what is the maximum profit? $540, and I believe that's per day. So it's better than $540 a year. And again, I graphed this one for you right here. So there it is. It opens down. See that function? Just typed it in right there. It opens down, and that point right there, 80 and 540 is your maximum profit. So if you're good with your graphing calculator, you can also graph these and confirm it like that. So again, we answered the question, what's the maximum possible profit? $540. So that is all about parabolas, and you should be able to use these formulas and answer some questions about finding the vertex and finding the line of symmetry using these formulas right here, and being able to tell whether something is a maximum or minimum based on that first coefficient of x squared. Let me know if you have questions, as always.